Hello everyone. Today we're going to start on Chapter 4, and we are going to be talking about Section 4.1. So Chapter 4 in general is on a topic called transformations, which is going to be some ways that we are going to be able to manipulate and change the way that a graph is going to look. The first type of change that we're going to be talking about is going to be something called a translation. Now, a translation is going to be a change that is going to move every point on a figure in the same direction or directions and in the same distance. Translations are called rigid motions because the size and shape of the figure is going to be preserved, which means your figures will not get any bigger or smaller, and they will not get any distortion. They won't get stretched out or anything like that. And so they will look very much the same. They will maintain the same orientation. Whatever was the top of the figure will still stay at the top, and whatever was the bottom will still stay at the bottom. Okay, so now, since we are changing the drawings that we are going to be looking at today, we're going to need a little bit of extra notation. And this notation that we're going to be talking about is called prime notation. And in general, prime notation means you're going to be adding in a couple of apostrophes. So, what we're going to do is we're going to start off with an original version, like a triangle that we might call ABC, which we've seen many times before, and we're going to call that original version the pre-image, emphasis on the prefix pre, which means it comes first. Then what we're going to do is we're going to transition or change that, and we're going to create something called the image. And when you name your image, what you want to do is you want to use the same letters, so we're still going to use A and B and C, but now what we're going to do is we're going to add in apostrophes, which are going to note that this is the new location of point A, the new location of point B, and the new location of point C. The way that we read that would be triangle A prime, B prime, C prime. You can also add multiple primes if you're doing multiple moves, but for right now we're just going to stick with one. Let's do one of these moves. So in our first example that we have right here, it says that we're going to be graphing a four-sided shape, so it's that A, B, C, D. And they ask you to plot the 4 points. I've plotted the points already right over here. Then B says, find the image of each vertex after the translation. So if you take a look at our translation right here, this is going to look a lot like what we saw in our exploration. It is going to take whatever points you have, it is going to add 3 to the x value, and it's going to subtract 4 from the y value. So I have actually also created this XY table, which uses all of the points that were written out in the original example. Now, from the table, what you can do is you can simply add 3 to every one of these x values. Negative 2 plus 3 is 1. 2 plus 3 is 5. Another 2 plus 3 is 5. And a negative 2 plus 3 is 1. So it's very simple, easy mathematics. You just follow whatever you have here and whatever you have here. Same thing for your y's. 6 take away 4 is 2. 4 take away 4 is 0. 1 take away 4 is negative 3. And 3 take away 4 is negative 1. Now we can just simply plot those points right there, and we'll be good to go. Let's start with our first one, 1, 2. So I would go 1 unit over and 2 units up. This is going to be my new location for point A, which I would call A prime. Okay, now that is not the only way that you can do this, though. You can also use your good old friend, the bunny hop technique. If you notice that you have x plus 3, that really means you're moving your graph to the right 3 units. And if you have something like y minus 4, that really means you're moving your graph down 4 units. So you can see that happening right here. If I start here at A, and I move to the right 3 bunny hops, and then I move down 4 bunny hops, I will end up at A prime. You can do the same thing for B. You could move over 1, 2, 3 bunny hops, and then down 4 bunny hops. And not surprisingly, you end up at the point 5, 0. That's the exact same point that we had right here. Our other points are going to follow that same kind of technique. So we have B prime right here. C prime is supposed to be at 5, negative 3. And D prime is supposed to be at 1, negative 1. Now, if you look at the shape that we are building right here, it is the same size and shape as the original, and it hasn't been rotated or reflected or anything like that. It looks like the exact same as what it looked like before. It's just in a new location. So that is a really, really nice translation right there. Okay, so now let's see if we can do the same type of example backwards. So this time what I'm going to do is I'm going to give you the pictures, and then I'm going to ask you to write out the rule for the translation. So the rules are going to look a lot the same each time. You're going to write it out with the same type of notation we saw in the last problem. So you have to start by writing this XY. Then you're going to put your little arrowhead in there, and you're going to write your new ordered pair locations, which will also start with XY. Okay, so now what we need to do is we need to decide exactly how this movement is happening here. So I see two figures, and unfortunately a lot of times when people see two figures, they almost always assume that we start at the left and we move to the right, because that's how you read when you're reading a book or reading a piece of paper. But you need to make sure you're paying close attention to the notation. So I see things like A and B and C over here on the right, but I see A prime and B prime and C prime over there on the left, which means that what's really happened is I've moved in this direction. Right there, I've moved to the left, and I've also moved up. Okay, so how far to the left have I moved? Let's find out. So if I want, I can bunny hop my way from one to the other very quickly and easily. 1, 2, 3. It looks like I've moved back 3 units, and it also looks like I've moved up 1, 2 units. Okay, so now to move back, we want to make sure that we don't put a positive 3 here, but rather a negative 3, so we can move back. And then we're moving up, which means we're going to use a positive 2. Now you can back this up by looking at any of the other points. For C right here, if I go back 3 units and then up 2 units, I'll end up at C prime. And the same would be true for B as well. So this is going to be my perfect rule right there. Okay, so now let's see if we can kind of simplify this. This next set of questions that we have right here is going to be a little bit simpler. So you don't have to draw the graph and you don't have to analyze the graph. All I'm going to do is I'm just going to give you a rule, and I'm going to give you a point, and I'm going to ask you to tell me where the point is going to end up. So this is a really great checkpoint question because it's not so bulky. There's not that much to do. You can just get it done really, really quickly. So now this point right here is being translated using this rule. Now you can set it up the exact same way that we had set it up before. You can make yourself a table, and then you can build your new table based off of your rule, and then fill everything in. Now if you also don't want to have to fill out those tables, you can just do this a little bit more quickly. If you take this 2, which is your x value, and you just plug it into the x spot, and you take this -4, which is your y value, and you plug it into the y spot. So then you'll end up with things like 2 minus 2 and -4 plus 5. It doesn't matter if you use the tables or if you use these algebraic expressions, you're going to end up with the exact same answer either way. That answer is going to be 0 and 1. And it's going to be 0 and 1. So you're going to end up with the ordered pair 0, 1 no matter what you do. So that works out really, really nicely. Okay, so now let's take a look at the second one. The second one is a little bit trickier, and the reason why the second one is trickier is because they have changed the wording on us a little bit, and it doesn't really seem like it would be that big of a deal, but it's a huge deal. What we have right here is we're asking for the pre-image, which means that what's happened is the pre-image is once again your first drawing, and the image, which is this guy right here, with the prime notation, is the final drawing. Okay, so now what's happened is this is the location where you end up at after this translation. So after you've moved 2 units to the left, you end up here, and after you've moved 5 units up, you end up here. So we need to figure out where this drawing started from before all that moving happened. So that means this is a bit of a backwards problem right here, and that can be a little bit tricky for some people. So I want you to make sure you're watching out for it. I find that to deal with these problems is easier if you use the equation technique. And so I'm going to do that. I am going to take my rules that I have right here, and if you use the rule, remember that you are actually producing this answer. This is the final location. This is the final image right here. So that means that this -3 is going to go into my little rule right here, but it's going to go at the back. This is where the final answer usually goes. And what I'm going to need to do is I'm going to need to figure out where was the original spot of the x value right there, and I'm going to do that by solving. I'm going to do the same thing for y. Y plus 5 is going to give me the answer of 6, and I need to figure out where the original place or the pre-image was before it got moved to the new spot, which is 6. Okay, so now to solve these, we're going to use our normal algebra techniques. when I solve the first one, I am going to end up with an x value of -1. So the original drawing started off with an x value of -1 before it got moved to -3. I'm going to do the same kind of thing for my second one. I'm going to subtract 5 from both sides. And it turns out that my original y value before all the moving happened was at 1. So the pre-image was at -1, 1. This point got moved 2 units to the left and 5 units up. And when it did, it ended up at this spot right here, which is going to be the image right there. That's tricky. Okay, so because that is tricky, I'd like you to practice it. I have 2 U-try problems that I'd like you to try out right now. Okay, here are the answers to your 2 U-try problems. I've set everything up using the table and the equation so you can pick out the technique that you like the best. Our first U-tried answer is going to be -1, 10. This is another image one, so we just do it the way that we like to do it by simply doing the subtraction and the addition the way that we see. This one is a pre-image one, which means we need to go backwards. So we're going to set up our equations, and we're going to have to solve them using opposite operations, and we're going to end up with our final answer right there. Okay, next. This technique that we've been using right here to write out our translations is not the only one. And so there is another one that some people like a little bit more because it's a little bit more concise and crisp to write down, but it also is a little bit more cryptic. It's harder to understand what's happening there unless someone tells you ahead of time. And that's what I'm here for today. I'm here to tell you about it so you can understand it. This other technique that we're going to talk about is the technique of using something called a vector. A vector is going to look a lot like an arrow, and it's going to look a lot like this on your graphs or on your pictures. A vector is another way to describe a translation. Each point on a figure will be translated by the same vector. A vector has direction and magnitude. So this vector right here, if you take a look, because it's got that arrow, it's going to tell you exactly which direction it's going to go in. And it's also got a length to it. So we have our direction pointing from our arrow, and we are going to have our magnitude showing up by the length of it. So you could have long vectors, or you can have short vectors. They can point in the same direction, or they can point in opposite directions. They can point in any direction they would like. But if you follow that vector, it will take you from one spot to the other. You can actually see that I've already drawn a vector. Right here, when we were talking about this picture right here, I drew a vector that took me from A to A prime right there. And that is the amount of translating we did and the direction of the translation as well. Okay, so now this is why some people really love vectors. A vector is going to have an initial point, which in this case right here is going to be point F. It's the point that does not have an arrowhead on it. And it's going to have a terminal point, and on this problem right here, it is going to be point G, and the terminal point always has an arrow on it. And when we're talking about the vector, we're going to use something called component form. And the component form is going to tell us about how far horizontally the vector is and how far vertically the vector is. And so this is going to be, in this case right here, if you count from one point to the other, you need to go 5 units to the right. And you also need to go 3 units up. Now, if we were going to write this out using our old translation rule, it would look like this. So you'll notice that it has the exact same pieces of information, which is fantastic, but this one takes a lot longer to write out, and this one's very, very short, which is why people like the vector ones. But once again, you can kind of figure out what's happening here. The arrow tells you that a change is happening, and then you can see the addition happening there and understand what's going on. This right here looks a lot like an ordered pair or a point. The only way to tell that it is a vector is because it has these angle brackets right here on either side. It does not have round brackets. If it had round brackets on either side like this, that would be a point. And that's also not what we want. So we want to make sure that we're staying away from the round brackets today. We are going to stick with our angle brackets when we are talking about a vector right there. Let's take a look at a couple of vectors. So when you're looking at a vector, it is just going to kind of exist in space a little bit for us. So we've got two vectors right here, and we're going to try to focus on them. The first thing we want to do is we want to name the vector. And you name a vector the same way you name an array. So you want to start with your initial point. In this case, it's going to be G because there is no arrowhead on there. And then it's going to extend towards H, which is going to be where the arrowhead is. Now, we also want to talk about the component form. Once again, the component form is going to use those angle brackets. And the big thing that you need to do is you need to figure out how far horizontally you have to travel to get from one point to the other. So I've done 5 jumps, and I've jumped to the right, which is positive. So I'm going to use a positive 5. Now, I also need the vertical component, so I'm going to come down. And I did go down, so that means it's going to be negative. And I went down 2 jumps. So it's going to be a component form of 5 comma negative 2. Okay, I'd like you to try out number 2 right here on your own. See if you can get a good answer for that guy right there. Here is our answer for problem number 2. It is RS, and the component form is negative 7 comma 0. So now I want to make sure that you notice that these answers right here are not acceptable. You cannot call it SR with the arrow going to the right, and you can also not call it SR with the arrow going to the left. That doesn't exist and that will not work. So it has to be called RS with the arrow going to the right. The components right here, we are marching ourselves to the left 7 units, so it's going to be negative, and it is a 7. We are not going up or down at all, so the component is going to be 0. Now, if we had written this out the old way, you'll see that we wouldn't have actually used anything on the y's. We would have just left it as 0 right there. But because this is a vector, we need to make sure that we include the 0 right there. Okay, great. Let's take a look at our next one. So our next example right here, we're going to try to use a vector in component form to translate. So this can be done a couple of different ways, and I'll show you both techniques. This is the same 2 techniques that we used on the front side as well. So the first thing you can do, once you're given a picture, is you can actually find the locations of all of the dots and make a table, just like we did before. Then you can adjust all those answers using these 2 values right here. The first value is going to be the adjustments that we make to the x's, and the second value is going to be the adjustments we make to the y's. So I can take these x values and simply subtract 4 from them. 2 minus 4 is negative 2. 5 minus 4 is going to be 1. And 3 minus 4 is going to be negative 1. There's the negative 1. Sorry about that. Then for our second one right here, we're going to do the same kind of thing. We would add 1 to each of these. You can also get this job done by actually counting on the picture. You can use negative 4 to take you to the left 4 units. And you can use positive 1 to take you up 1 unit, and that will tell you where your new location is right there. It doesn't matter which technique you use, whatever one you like is the one that you should use because it'll be most comfortable to you. Sorry folks, I had missed a negative sign right there, so I'm going to put that in. Go. You can see that the 2 triangles are the exact same size and in the exact same orientation. They haven't changed in any kind of way. Okay, for our last example that we have right here, we are going to actually take a look at 2 translations. When you have 2 things that are happening to your drawing, we call this a composition. So now I have started off by drawing my original segment, which is called RS. It has points that are at negative 8, 5 and negative 6, 8. And then what we want to do is we want to translate it twice. Now you can translate this twice on the actual diagram itself, or you can translate it using your tables, whatever makes you feel best. I'm going to use the tables because I think it's really, really fast. So I'm going to take my negative 8 and I'm going to subtract 1. And I'm going to do the same thing for my negative 6. I'm going to take my y values and I'm going to add 4. And 4 again. Then, now, when you do your second translation, what you want to do is you want to do it to the final answer that you just came up with. So we're not going to go back to the original pieces. We're going to take what we just created and we're going to perform these translations to that new piece right here. So I'm going to take my negative 9 and that's what I'm going to add 4 to, not my negative 8. And I'm going to take my negative 7 and I'm going to add 4 to that as well. I'm going to take this positive 9 and I'm going to subtract 6 from it. And I'm going to take this 12 and I'm going to subtract 6 from that as well. Okay, so our final result, the final location, is going to be based off of these points right here. And that is going to be located at negative 5, comma 3. And it's going to be located at negative 3, comma 6. This point right here would be R prime prime. It's gone through 2 translations. And this point right here would be S prime prime. It's gone through 2 translations as well. Okay, that's everything that I have for you. It's time to move on to the homework assignment.